Hi, we're Group 12, and we're here to teach you about physics demonstrated through sport. Physics is basically how the world, really how everything works, and I'm not sure about you, but in the world I live in, things tend to move around a lot. Today we aim to look at forces and how they make things accelerate, and from that we turn to a physicist many have heard of. May it be from the story of an apple falling onto its head, or calculus that made many fail exams, Sir Isaac Newton and his 3 laws of motion.
Newton's first law of motion is practically all about inertia, but in order to know what Newton's first law demonstrates, what is inertia? Inertia is an object's tendency to keep doing what it's doing, or an object's resistance to a change in its state of motion, if you may. For example, if I was to put a football on the ground, just like that, it is, and it will stay in its state of motion, unless, I was to kick it off the ground. Newton's first law of motion is often defined as an object in motion will remain in motion, and an object at rest will remain at rest unless acted upon by an external force. An object wants to keep doing what it is doing, and it will only move unless a force was to act upon it. But what will happen when I apply force onto an object? Will it stop? Will it move? Will it fly? Yes, no, and or probably not. I do not know. But what I do know is that there are 4 outcomes when a force is applied onto an object. The object can either increase its speed, decrease its speed, change in its direction, or change shape. But when adding a force onto an object, the more inertia the object has, the more force is required to make it move. That makes sense, right? The more an object wants to keep doing what it's doing, the more force is required to make it stop doing what it's doing. And this is where Newton's second law comes in handy.
The second law of motion is often defined as force is the product of mass times acceleration. The formula for this is F equals ma. So Isaac Newton's second law of motion tells us how things accelerate depending on the mass of the object and the force being applied to that object. In order to make things accelerate or speed up, force must be applied. The greater the force, the more speed the object will achieve. 2 footballs, for example, both with different masses. The football with the greater mass will require more force in comparison to the small football in order to kick the football through the goalpost. But one ball has a smaller mass as opposed to the other. The ball with the lower mass will require less force applied to it, allowing it to go through the goalpost. Likewise, another suitable example is moving furniture. 1 couch versus 1 stool. If the same amount of force is applied to both, the stool will move further. This is evident throughout our experiment, balloon rocket, as the more air you blow into the balloon, the more distance the balloon will travel.
And finally, Newton's third law of motion, summarized as for every action, there is an equal and opposite reaction. Forces always come in pairs. A force will be either a push or pull, a towards or backwards, an up or down, as a result of an interaction being made with another object, otherwise known to as a normal force. By normal force, we mean perpendicular. This basically means pointing straight back up in a straight line, opposite to the force of gravity. Say I was to push down on something as microscopic as this table. I am applying force towards the table, and the table is applying the same amount of force back. But when is this not the case? I have a bucket covered with aluminium foil. I add a fruit that weighs 1 Newton. The fruit exerts force down onto the foil, accompanied by gravity, and the foil does the same thing by applying the same amount of force back on the fruit. But keep adding more fruits onto the foil, the aluminium foil will eventually collapse. This is what happens when the amount of normal force provided can match the amount of force being exerted. But a more profound example, just for you guys, goes a little like this. Say you have a friend about to try, but he accidentally slips and drops the ball, committing a drop ball. Bummer. the ball will hit the ground, exerting a certain amount of force to the ground. This is the action. The ground will react by exerting the same amount of force opposite to the ball, and this is the reaction.
Car crashes is another example. This is the action, and this is the reaction.
Relative to the rocket balloon experiment again, the escaping air exerts a force onto the balloon itself. The balloon pushes back in a manner described by Newton's third law of motion. That opposing force, called thrust, in this case, propels the rocket forward, i.e. action and reaction. Now you've learned mostly everything there is about Newton's three laws of motion. Inertia, F equals ma, normal force, and why things accelerate, all through sport. We are Group 12, and I have no closure. Retake.